We'll see today lecture 3 from chapter 1, that is the Intel microcontroller 8051. Myself, Dr. Faiz Ahmed Kurne, Head Department of Electronic Science, Abeda Inamdar Senior College. In today's lecture, we'll see the pin diagram of 8051 microcontroller and its description. Let's see the pin diagram of 8051 microcontroller. This is what I see designed by Intel company, and you can see the value written over here, that is 8051. You can see here 8051. Then one more IC designed by Atmel company, it is 8089S52. Both are similar with change in RAM and ROM. Then we have one more IC by Intel company, that is D87C51, and Atmel company, they have their IC, that is 8089C51. So only differences is either 8051 or 8052. I already explained this in my lecture 1. Let's see the IC. This IC is 40 pin DIP, that is dual in package. That means each side contain equal pin, that is 20 plus 20 pin. Out of these 40 pins, 2 pins are for power supply, 32 pins are used for parallel ports, 2 pins are used for crystal, 1 pin is used for reset purpose, 1 pin is used as ALE, 1 pin is used as PSEN, and 1 pin as EA. So total 40 pins are used as follows: 2 for supply, 32 pin for ports, 2 for crystal, 1 for reset, 1 for ALE, 1 for PSEN, and 1 for EA. This is the IC. You can see 20 pin on the left side and 20 pin on the right side. So we have total 40 pins. You can see this diagram. So you can see this 2 pin for power supply, VCC and ground. Then 4 ports. So we have 32 pins for ports. Then EA pin, ALE pin, PSEN pin, 2 pins for crystal, and 1 pin for reset, RST. This way total 40 pins are used. Now let's see description of the pins. So 2 pins are used for VCC and ground pin, because we need a power supply. So pin number 40, it is always connected to positive terminal of supply, and pin number 20 is called as ground pin. It is always connected to negative terminal of supply. You can see in the diagram. So we have 1 pin for positive supply and 1 pin for ground supply. So 2 pins are used for power supply. Then for ports we have total 32 pins. So for port 1, 8 pins are used, 1 to 8. For port 3, again 8 pins are used from 10 to 17. For port 0, pin 32 to 39 are used, and for port 2, pin 21 to 28 are used. You can see on the IC, right side has got even number of ports, and on the left side we have odd number of ports, that is P1 and P3. P1 each port is 8-bit size, hence we have total 32 pins used for ports. Each port can be used as input or output. So all ports are bidirectional. Port 0 is referred as P0.0 to P0.7. It require external pull up register. It has 2 functions. One can be used as simple input output port, and port 0 is also designated as AD0 to AD7, so it can be used as A0 to A7, that is address, or D0 to D7, that is data line. And you can use this port 0 along with the port 2. Port 1 is also an 8-bit port referred as P1.0 to P1.7. In this case, we does not require external pull up register. It has only one function that can be used as a input or output port. Port 2, that is P2, is an 8-bit port referred as P2.0 to P2.7. Here also no need of external pull up register. Its main function is similar to port 0, so it can be used as a simple input output port, or can be used as address port, that is A8 to A15. A0 to A7 are used by port 0, and A8 to A15 is used by port 2, and hence can be used along with the port 0. Port 3 is 8-bit referred as P3.0 to P3.7. It has additional functions along with simple as input output. So you can see here it can be used as a serial communication, interrupt, timer, and 2 pins are used for write or read operation. So RX for serial input, or TXD for serial output, INT0, INT1 are external interrupt 0 and 1, T0 is timer 0, T1 is timer 1, WR is external data write, and RD is for external data memory read strobe. PSEN is called as program store enable. This pin is used to enable external ROM, or we can say external program memory. So it remains low while fetching data from external ROM and remain high when the data is accessed from internal ROM only. The next pin is EA bar, that is external access pin. This pin, we know that the 8051 has 4 kilobyte of ROM. If EA bar equal to 0, then the 8051 will discard its internal ROM and can access data from external ROM. And when we make EA bar equal to 1, then 8051 can access internal ROM as well as external ROM. If we do not have external ROM, it is better to connect this pin to plus VCC. Then there are two pins for connecting crystal. They are X2 and X1. So we connect crystal across these two pins. The crystal can be of value 11.0592 megahertz or 12 megahertz. This is the crystal 11.0592 megahertz, and you can see here the crystal is 12 megahertz value. And in this way we can connect the crystal across X1 and X2. Next pin is ALE, pin 30. It is called address/enable. It is used to separate address and data bus. So it can demultiplex AD0 to AD7 of port 0. So when it is 0, we can use port 0 as simple address bus, and when it is 1, we can use port 0 as data D0 to D7. Last pin is reset pin. This pin is used to reset 8051. We can reset in two ways, that is power on reset, or we can reset manually. For this we require resistor and capacitor and one push button switch. You can see the diagram here. So here we require one C along with resistor.